So we just created the single person whipping angel, which works like this. Now we have to convert this into a multiplayer one, and I'm going to make it from start again because it would be, because I'm planning to create like this as a completely different video. At first I wanted to have both in one, but I made the first one way too big, so I'm kind of going to speed it a bit around here. So if you want to learn more in much detail, also watch the first person one so that you can understand in much more detail. But this one I'm going to go faster because this is a bigger one, and if the first one took this much time, then I don't want to spend this like much longer than the first version. Okay, so let me first show you guys what we are going to do. So I'm going to add my multiplayer one. Okay, I'm going to show you the multiplayer version. So I'm going to do 3 players, single player, listen server, and then so you could see that this is how it looks for the multiplayer. It's not moving. I'm going to turn all of them away like this, and then you could see as soon as one of the players starts going outside, it just starts moving towards one of the player like this, which is kind of creepy, but that's the point. And if I go outside this box, you could also see one more thing, that the line trace only happens on this one, which is the server, and on the client 1 and 2 we are basically not even sending any information except the player location of the enemy location. Basically it is automatically getting replicated, so we don't even need to do much. But you could see that if we get blocked like this, if no one is watching, but if this is getting blocked, it starts moving towards that player. Okay, so I'm going to go here, it's visible around here, so let's go like this. And you could also see that every 5 seconds there's a name popping around here, and that is because the target is getting changed every 5 seconds. Obviously in original game, if you're making, you would make it much more longer, not 5 seconds, or probably like 30 or 1 minute. But in here, in this case, I set to 5 seconds just for the debugging purposes, but you could see how nicely it works. So let me give a quick breakdown first, and then we'll start making. Okay, so first of all, I have added a nav mesh, which you basically just add around here like this nav mesh, and then you have to scale it up. So you basically scale it up and down so it covers this one. And if you press P, you could see this is where your AI character, which is this one, can move towards. Okay, so it will automatically find a location to move by just avoiding the obstacles like this. Okay, so if you're standing here, it will basically just move like this. If you press P, you could see this. If you press P again, you can hide this. So if you watch the last part, which is single player, you would kind of get an idea of what we need to do, but it's just a bit bigger right now because we have to loop a lot of the time. Okay, it's very simple, it's not much complicated, so just bear with me. Okay, so I'm just going to give you an overview, and then we will basically just start making it. So at event begin play, I basically get the game state, and then I cast to my game state. It's okay to cast to the game state because the game state is always going to be loaded in our memory. Okay, so when we add this multiplayer or this multi whipping angel on the level, we don't have to worry about creating a cast because this is already in the memory. Okay, but you shouldn't do opposite way, where you shouldn't, in your game state, you shouldn't cast to your whipping angel, because then what would happen is if your level doesn't have this whipping angel, it will still be loaded into memory. So just know how to use casting. I already have a soft reference and hard reference video which goes over soft reference and like casting interface and all. But because it is already loaded, we can basically just cast and basically just save a variable. Okay, then I have a function name. Basically every 0.1 second we check if the player is looking or not. Okay, if the enemy has been looked at or something or not. And then this is another one, choose player to follow. Basically every right now it's 5 seconds, so every 5 seconds the player that needs to be targeted is changed. So move to player, which is this one. Oh sorry, not this one, by the way. So move to player is basically just moving towards the player. Okay, if the player is looking, then we basically just stop it. Okay, we are not going to move our character at all. We already did this in the first person version, first single player version, I mean. And for the false, we already did the same thing. So nothing's really changed from the false part except this target actor. Okay, so this target actor is basically chosen randomly. So from the single player version, this is the only thing that we have done, where we basically stop the movement if our player is looking at it, and then we set the movement is moving to be false, basically telling that we are not moving. And then for here we can basically just go to false. We can check that if we are already moving. If we are already moving, then we don't need to run this code again and again, because we can save what you call like computing power from this, right? Because we are already moving, there's no reason for us to calculate it again and again, like this new location and all. So we basically just say we are already moving. If we are all not moving, then we basically find where we need to move, and once we know, we basically set it to be true. Then this is the main stuff where we need to check if the player is looking or not at the, if all the players are looking, or if even one player is looking at the weeping angel or not. So we basically just do if this is valid or not. It's basically this stuff, okay, where we basically created a variable for the game state. We basically check is it valid or not. And the reason why I'm using game state is because game state already has the player array. So any player that has joined, it has the copy of it. So instead of doing something, let's say get all actor of class, which is like complex, or doing something else, our game state already has this option called player array, which has player controllers or player state object reference, sorry. So we can basically just get this. We get all the players in that array. We basically start looping. So the game state has player state, and we check which player which pawn is using the player state. This pawn is nothing but your character, or whatever you're possessing, but by default it's going to be character. We also add a valid just for safety, and then we set this as the colored player in group. Ignore the completed for now, okay? So first we get the player, first player is added in the loop, and then we do one simple check, which is this dot product check. Okay, it's very basic. We get our current player which is in the loop, and we check which direction it is facing. Okay, we get 0 to 1 value because it's a forward vector, right? So we get 0 to 1 value, and then we get 3 values. Basically it's a vector, so 3 values in 0 to 1 fashion. So the next thing we do is we find the direction from the player to ourselves, which is the enemy, like this. So from the player to the enemy, which is simple, you get the location of the player, you get the location of ourselves. We basically do minus, so from this to this, and then we basically normalize it, so everything turns to 0 to 1. All 3 values turn between 0 to 1, and then we check the dot product. Dot product is like very basic. So the way dot product works is that we are already getting the actor's forward vector, right? So the forward vector would be whichever direction we are facing. So if we are facing this one, facing this one, facing this one, and then we have this one, which is normalize. This one basically gives us the direction from the player to the enemy. So if this is A and this is B, you could actually do minus of like vector B minus vector A, and then you normalize this, and it basically gives you the direction from this to this. You could just think of it as destination, like destination minus the starting, like this. Okay, so destination minus the starting, and then you get basically, why is the wrong stuff getting what you call disappearing? We basically get the direction from player to the enemy. So the way we can do is we can compare our forward vector where we are facing. If we are facing this direction, then we will know that we are facing the enemy. If we are facing around here, we will know that we are not facing towards our enemy. If we are facing here, we know we are not facing towards the enemy. So the way dot product works is that it compares your forward vector, like any two vector basically. So we compare our forward vector, and if the forward vector and this direction vector is same, then we get 1. If it is like this, where one is facing this way, and then let's say our player is facing this way, then we will get this as 0. If our player is facing this way, then this one and this one is opposite, right? So this one and this one is opposite, will get -1, like this. and this one is 0 because it's facing, if we are facing this way like this and if you are facing at the same direction, we get 1. So as we go forward, it will go like 0 0.1, 0 0.3, 0 0.4, 0 0.5, and then dot 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 like this. Okay, so wherever we are facing, we'll get like different values. So we can basically say that if a dot product is more than 0.5, this player is looking at the enemy, looking at the whipping angel. If not, then we can basically say that is observed to be negative. Is observed is basically something I created, which is a variable which is saying that I'm not getting observed, like this whipping angel is not getting observed. Basically, if it's not getting observed, then we have to move it. If it's getting observed, we have to stop it. So if this is false, we basically have to set this to be false. Okay, if it is true, we need to do one more check, that is there a wall in between, because if let's say our player is looking at the enemy but there's a wall in between, then the whipping angel is not getting observed, right? So we need to do a test, and it is very basic test. We get our location, we get the player's location, we do a line trace, basically a line trace, and check if there's something in between or not. If there is something, then we will get true, which would mean if this is true, like if something is getting hit because of wall, then we are not able to see the whipping angel because there's a wall in between or an obstacle in between. If this gives us false, which means nothing's getting hit, it means we have direct visibility with the whipping angel, which means we have to stop it. So is observed. Okay, so if we are getting hit, we are not getting observed. Okay, yeah, I've set it not, and I usually when I use not like this, it's kind of confusing. So we are basically turning whatever we are getting around here to the opposite and setting this as is observed. So if there is a wall, we can say that we are not getting observed. If there is no wall, which would basically say that if there's no wall, it will give us false, then we are getting observed. Okay, and then because I'm using here for each loop with break, as soon as we find that even one guy is looking at the whipping angel, we can just break the loop. We don't want to loop forward because we know that one guy is looking, so we have to loop, we have to set true and basically just say that break. Okay, the reason why I had to do this is previously it didn't work nicely, and I'm just going to explain this code once so that I don't have to explain again and again. Let's say this is our whipping angel, like this, and then we have players like this, like 1, 2, 3, and 4. Okay, the way loop works is that it will first check for this player, then check for this player, then check for this player, and then check for this player, right? Let's say we find that this player is looking at our whipping angel, then we find this is also looking at the whipping angel, then we find this is also looking at whipping angel, but this guy is not looking at the whipping angel. So because this happened 1, 2, 3, 4 are not boolean, is observed, right? What is it called? Is observed. Okay, so is observed boolean was set to true, 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 and suddenly false. So when the loop ends, it's going to say that okay, it's false at the end, I have to move towards the player, because if you do full loop, then it will only check the last value. Okay, because the loop because it doesn't matter what happened in here, it will basically just do last loop or whatever the last character is, and if the last character is not looking, then it will be like, hey, nobody is looking at me. But we don't want that. We want, as soon as we find that someone is looking at this one, we basically want to just say that, hey, this is the value and we are getting observed. If this guy was not looking, let's say if this guy was not looking, we'll go to the second guy and then be like, hey, are we getting observed? Yes. Then we'll say is observed, and then basically just not even check the third and fourth, because if you do check that, then it would cause a problem, which is it will only find the last one's value. And then this is random player to follow after interval. This one is nothing, we basically just choose a random random player, same way, like getting the player array, getting the pawn, and then setting this as the player target pawn, And then around here you could see every 5 seconds it basically just runs this code. So whatever we have a target point, we'll move towards it. So how about we get started and let's start making it. So I'm just going to go to the tutorial one that I created previously. All I have in here is a tutorial whipping character. It's a basic third person character, nothing else. The only thing that I've done is I added the mesh. It's a first person character. I added a mesh around here, called it skm many, and then I set it to be owner no see. So basically we cannot see, but other players would be able to see it. And then I gave it abb manage see animation, so that the animation works basically. That's all I did. One more thing that I did was I created a new player controller by going into blueprint, click player controller and name it anything. This is how it looks, the player controller. It's very basic. If you're using, let's say, default third person, you don't even need to do this. You basically add the mapping context in the player for that version, I think. But it's good to add this mapping context in player controller, I think. Okay, but know one thing, that for multiplayer, okay, the server, and then let's say client 1, client 2, client 3, this is basically players, and this is like the host. If the server is also the host, he would have a player controller, which is his own player controller, like local player controller, and a copy of all three of them. So player controller of C1, player controller of C2, and player controller of C3. This is just an architecture of multiplayer that Unreal Engine uses. And this one would only have his own player controller, his own player controller, and his own player controller, like this. So when you do something, let's say run any code in here, it's good to do is local controller. Basically, because our host has like 4 controllers, we don't want this code to run 4 times, which is why in our controller I've just said, is this a local controller? Yes, then only run this, because this is also local controller for this character, this is local for this one, and this client basically, and this one are just a copy. So just keep that in mind for multiplayer. Now I'm going to do is create a new game mode. We don't use game mode base for multiplayer, we use game mode like this game mode. It has like more features basically, so I'll call it pptut game mode, Vaping Angel or something. Okay, let's double click this and let's set this as the player controller that we created. Player controller, let's select the character that we have, the basic one, as the player character. I'm actually going to create a game state too, so let's do game state. So not game state base, but game state. Let's select this pptut game state vaping or something. Select this and then make sure the game state is set to this one. Now we can basically just say that where's the game mode, this one, use this one. Now I'm going to delete everything so that I only this much, okay, not everything. So basically a nav mesh is added, that you could just add a nav mesh like this, just drag and drop it here and then scale it to whatever you want, and then press P to show where your AI controller can move. And then this is just an obstacles that you could basically change, and wherever there's an obstacle it will find a way around it, and it will basically not be able to run around it. Okay, so green part is where your enemy would be able to move automatically. Let's just see if playing does anything. Okay, it's working basically. Multiplayer is automatically working. You could see that others can see, but we cannot see ourselves. Let's create a new blueprint class. We have to use character or pawn, because this AI nav mesh, it only works on these characters and pawn, because it has the option that is added the AI controller code is been added to this one. Okay, so let's call it BP underscore TUT. I'm just going to call it WA and then multi. So WA for what you call weeping angel. Let's add a mesh. Let's do minus 90 and this one also minus 90, like this. One important thing I want you guys to know is that right now you could see the red arrow is showing on this side. This is the front vector, oh sorry, forward vector. Green is the right vector and blue is the up vector. If you think that if you try to set, let's say, get forward vector of this mesh, it's actually going to be the left of it. Okay, which is why we simply just can use the capsule collisions forward vector. I'll explain in a bit, but usually because this is not made in it's not, this mesh is not made to face red color by default. It's actually not facing the forward vector, it's actually facing the right vector. There's a reason why I'm saying this, so I'll explain in a bit. So let's go to the event graph first. Let's start moving, making some stuff. So our first stuff is to get the game state so that we can have all the players. So let's do game state, and then we'll actually do cast to game state, TUT game state weeping, this one, and then we can basically just save it like this so that we don't have to do cast again and again. And we don't have to worry about casting because we are doing from this character to the game state, and game state is always going to be in your memory. So we are always going to have it in the memory. If you want to know much about casting and interface, then please check the hard reference versus soft reference video. It explains when you should use casting and when you shouldn't. So I actually opened like a reference, the previous one that I created, so that I remember. So the first thing I'm going to do is we are going to check if the player is looking at the weeping angel or not. So let's create a custom event and let's call it check if a player is looking or something like this. Okay, you could name it anything. And one important thing, this should run on server. Okay, so we want all the calculation to happen on the server and not on each client. So everything that we are going to do is going to run on server. So first of all, we'll get our game state and we'll check if it is valid or not, just for a safety purpose. Like, is our game state valid? It's probably going to be valid. If it's not, then your game would probably not even run, I think. If it is valid, we'll do get again, and then we'll get player array, and this one gives us the player states of each player state. If you go into blueprints like this, you will find there's something called not here, like player state. So by default you could create your own extra one, but by default Unreal creates like a default version, but ideally you should make yourself another one in case you are making like a whole game. Now what we need to do is we need to do for each loop with break. So like I explained before, I don't know if I still have this. Okay, no, I don't have the drawings, but we want to stop this as soon as we find that one of it is looking at the enemy. Okay, because if one of it is looking, we don't need to calculate if others are looking out or not. So this array element is going to give one of the player arrays. So let's do is get pawn. So we get which is been controlled by the player state, like this, and then let's promote this to a variable and call it as current loop player, like this. Let's go in here loop body, so it runs every loop like this. I can actually do one more valid around here, and if it's valid then only set it. The reason why I'm doing this is because what if someone disconnects and also I want to make sure is valid, and then set current loop player like this. And now we do the same thing that we did for the single player. We get our current loop player, we get It's forward vector. So which direction the player is looking. Now we need to compare where he's looking and check if he's looking near the what you call the weeping angel or not. And the way we do it is we compare this direction with the direction from our player to the enemy. Okay, I just want to draw just so that I can explain it in a better way. This is the enemy. Okay, so we this direction would always be same, right? Because it's always from player to enemy, and then this one is going to be changing based on where the player is looking. So the forward vector will always change based on where it is looking. Now keep in mind that when you want to find direction from player to this is A and B, right? So we do this minus this. So we do position of this one, which is a vector, minus VA, and then we normalize this. But keep that in mind. We do this to this, because if you do opposite, it would turn to like this. Okay, it would show direction this one, and then if you're looking at the player, then what would happen is it would give you -1. So it will always be wrong, because you're not getting the direction from this, and then forward vector would be like this, else it would always show opposite direction. So make sure you do the same method, okay, like this. So this is the forward vector. So let's get our world location. You could just do like get actor location, and it will give you your location because it's an actor in the end. Or you could just do this one too, which is get self reference, get world location, capsule component, and this one will also work. Okay, so it's your choice which one you want to use. Minus the current loop player location, get actor location, like this. And then we basically do minus from one to another. So we do minus from the enemy, which is us, to the actor. So we do B minus A, and then we get the vector. If you do normalize after this, then we get the direction from the player to us, which is this enemy right now, and we get the direction basically, and then we just compare it with this using dot product. I'm sorry if I'm confusing you guys a bit, but I'm trying to explain it in the method that I know. And then we basically do is this one greater than 0.5? Again, play around with values, 0.6, 0.7, whatever works for you. 0.5 works for me better because if you use 0.6 and all, then even if he's visible at the edge, he still starts moving. So 0.5 works best to me. And then we'll create a branch. So if you hold this and do branch, we get a branch like this. And then let's add this as check if player is looking, or something like this. If this comes to be greater than 0.5, then we are looking at the enemy. So how about we just test this much first? I like to do testing every phase. Okay, it's easy to do it that way instead of doing everything. Looking at enemy, let's copy this and do not looking at enemy. Let's turn this to red. I'm also going to do one more thing. This one I'm going to give it, you could also give it like the animation if you want. But what I'm also going to do is I'm going to give it an overlay color so that we can see it easily. The overlay material is like very basic. You could check around here. It's basically I change this to additive, changes to unlit, and then just gave it a red color. Okay, that's all I did. And then I can give it around here. I think it basically creates a copy of the mesh on top of the another one, and then gives it the second color like this. This way we can actually see it much more easily. Now it is set to 3 players, play as listen server. Let's do play and see if it does anything. We forgot to do one thing, that is to run this event. So on event begin play, let's do set timer by function name, and then we can just copy and paste this name, the same name, into here. And then I'll say every 0.1 seconds run this and loop this. So every 100 milliseconds it's going to run it. And then in future, if you want to stop this loop, you would promote this to a variable calling as just call it like something, I'll check timer loop or something. In future, let's say you want to stop it, let's say your players are way too far and you want to stop it. In that case, then just save it like this, and then in future or wherever you want to add this condition, just type clear, and then it will basically stop this timer from running or from looping basically. But for now, let's just do it this way. Let's see. Right now it says looking at enemy. Now you could see that it's saying not looking at enemy. I don't know what's happening to the third player. It's not spawning correctly. Okay, there we go. So 2 of them are looking at the enemy, 1 of it is not. 2 of them are looking at the not looking at the enemy, 1 of it is looking, which is this one, and now none of them are looking. Okay, so it's working perfectly. So let's remove this. We will create a variable and call it is observed. Okay, is observed basically means that is this weeping angel been looked at, is it been observed, and we'll basically set this as false around here. So every loop we are basically just setting it to be false. Okay, now what we actually have done here is we have found out if the player which is in the loop looking at the enemy or not. But there's one more thing, that is obstacle. So if he is looking at the enemy, is there an obstacle in between it? Because if you don't do that, then there's a wall in between, and if there's a wall in between, then it would still be considered that he's looking at that direction. But we actually want to confirm that there is no obstacle in between. So the way we do this is we do line trace by channel. Let's do true, and then we could do is you could do from any direction for this one. So let's do get actor location. So from this location to our self location, so self reference get world location capsule component like this. So from start, which is this player, to us, or you could do opposite to it, doesn't really matter for this case. Just keep in mind that let's say your trace is going at the bottom. Let's say if you selected mesh, it actually goes towards origin, right? Then you could do something like add, let's say 50 around here and something. So from the world location, just add 50 or something if you want. I'm just going to do the basic one. So we are just doing a line trace from the player to the whipping angel, and we only do this line trace if we find that the player is looking at it. If we find that the player is not looking at it, we don't need to check the line trace, because again it doesn't matter if there's a wall or not if the player is not looking. So you could say we turn to false. The trace channel is set to visibility. I would suggest making a new trace channel for it, like your own trace channel. You could do that by going to edit project setting. I'm not going to do that, and the reason for that is right now if you go to collision, it should not cause any issues, but you could see that the collision is set to ignore. So if our visibility was coming from inside, like the ray, let's say this trace, and if it was coming from inside, it would have been blocked if this was set to block. Okay, Same with the mesh, but for my this example it is set to ignore, so it's okay. But in case you have something, let's say another your own model or anything, then make sure you are using your own line trace just for safety purposes, nothing else. Or you could just turn this to ignore also, okay. Or a safe thing that you could do is you could create a scene component and it call it like trace start or something, and then place it outside your like complete character and all that stuff. And then instead of doing self, could just do is trace start and get its world location like this. So instead of getting capsule 1, we basically get the start trace start, and then that's where it ends. We want to actually draw it so that we can actually see the trace. So all we simply have done is create a trace from one location to another. That's all we have done till now. So let's test it quickly. You see that the trace is happening to all the 3 players, but we cannot see the trace in here. Why? Because it is done on server only. Now here's the problem. Okay, what's actually happening is it is looping through each player, and then it is checking, hey, is he looking at me? If he's looking at me, do a line trace. In this case, all 3 of us are looking at it. You could see all 3 of them are looking. We don't really need to calculate for the rest too if only one of them is looking, right? It's unnecessary more calculation, because if one is looking, the weeping angel stops. So we will create is observed based on this. So let's do is observed. So if there is a wall, like if there's a wall, we are not getting observed. Okay, this one would give us true if there's a wall hit. This one would give us false if there's no wall hit. If there's a wall hit, we are not getting observed. If there is no wall hit, then we are getting observed. So because it turns to opposite one like this. And then I'll do a branch like this, and only for the true one, okay, only for the true one, I'll just drag this around here. I know I can create functions and all, but I would just make it like this. It's easy for my brain to understand instead of creating function, at least at this stage. So here's what's happening. If the wall is getting hit, we are seeing the wall is getting hit, we are not getting observed. So do nothing. But we need to do one more thing. That is this completed pin. This runs on 2 conditions. Okay. If something is broken, like something comes up and breaks, it will run this completed. Or if the whole code runs without getting break, it will still run this. I tried with ChatGPT to understand this. The ChatGPT was just giving me wrong thing. Okay, the ChatGPT was saying that if you break it, this does not run, and that's why I was spending I spent like hours on it to understand it, until I manually tested it and found that this one runs even when you break it. This would run completed if the whole loop is completed or something comes up and breaks it. So all we simply need to give here is move, like move, and then give the information that are we getting observed or not. That's all we need to do, but we haven't really created the move option. So let's create the simple custom event move to player like this, and I'll create a boolean in here which is going to be is player looking like this. You could name it anything. Okay, my throat is giving up. I'll just do branch. If a player is looking, we actually need to instantly stop our movement. So stop movement immediately. And the reason why we do stop movement immediately is because if the player is, let's say, running, the weeping angel is running towards a player, as soon as we look at it, we want to stop it. If you don't do that, then it will keep running towards that player. So we want to stop it instantly. And then for less calculation, I'm also going to create another variable called isMoving. So are we already moving or not? So as soon as we stop, we are going to stop moving, right? So let's just turn it to be false. Around here we'll do one more thing, which is called AI move to. This one requires a character or pawn class, which we already done, and nav mesh. Okay, we need to actually move towards a location. So this one is going to be self. We want to move ourselves, but the target actor is going to be random. So before to do that, let's create a quick custom event and like random player or something. This is like very easy to do. All of this should run on server. Okay, all this event should run on server. I totally forgot to do that. So run on server, run on server, run on server. I think even if you don't do that, it would still run it, but I think it's safer this way. We can get our game state. We could do get player array like this. We can do random array item. Let's do get pawn and promote this to random selected target, something like this. And let's choose this around here. Make sure we have to run this first. So let's create another custom function name. I will loop it every 5 seconds. Ideally you would do like, I guess, 20-30 seconds or something. And then let's select this name, random player, add it in here. Just remember, when you use set timer, and let's say if you set it to, let's say 30, it would not instantly run, because it actually acts like a delay also. If you don't click loop, it acts as a delay. It's actually an alternative that you have to use. If you watch some videos, they would say that you have to use timer, just don't use delay and all. So you could learn that there, but for now I'll explain one thing, that if you set as 30 seconds, it would not run instantly. This random player would not run instantly. It would wait for 30 seconds, then run. Then it would wait for 30 seconds and then run. But we don't want that. We want it to instantly run and then wait for 30 seconds. So there's something called initial start delay. Initial start delay, where you could just type -30 or something like this, and we'll just do -30 for the initial start. So instead, just promote this to a variable and call it as this random timer like this, and then just multiply this by -1 and add it around here. That way you just need to change the value around here, let's say 5, and it will automatically work it. So we got our random selected target. So in our move player, we'll basically take our random selected target and go to our target actor like this. But there's one more thing that I want to do, that this move to player, it might constantly give us false, like if no player is looking, because we run this where is it, 0.1 seconds, right? So if this code constantly sends like 0.1 seconds, that move to player, move to player, move to player, move to player, when nobody is looking, then it would get like much more complex, because this calculation is probably like much more complex, which is why we created is moving variable like this. And we will just check this. We'll actually do branch, that if we are already moving, let's do a print string around here. We are already moving, then we'll do nothing basically. Let's do like yellow. If you're already moving, we don't need to do move again. Okay, we are already moving, so we don't need to constantly calculate and do move to like this. But if we are not moving, then we'll do this. But because now we have started to move, we have to now set is moving to be true like this. So all this is moving is around here only. We say not moving when we stop the movement. We say moving when we start the movement, and here it's basically the code will go we are already moving, then it will basically just try to run this, which is completely going to be empty, so that this code does not run constantly. Now let's go to move to player, and on this completed state, right, in this one, as soon as we do break, let's say if we do break is observed, which means one player is looking, then we'll break it, then we can basically say that this is completed. Just start doing whatever you want, which is move to player. We want to move to player like this, based on is observed. So if we are getting observed, it is same as saying is player looking. Okay, getting observed is player looking, kind of same. So if we are getting observed, which is true, then we'll basically just stop the movement, and if this comes up to be false, then we will just start the movement, like start the movement. Let's confirm it once, and you could see that line trace. Now you could see the line trace. Let's wait for it to disappear. It only shows to one character. Why? Because it has already found that one of them is looking at it, so it doesn't need to calculate for the rest of the two. But if I move outside, you could see that a line trace was created to the second player like this. You could see. So let's turn this one, let's turn this one, and this guy, let's turn, and you could see it's moving. We can also press P. I think I can only press P in here. No? Can I not check the nav mesh in the multiplayer? I think in multiplayer it does not allow nav mesh checking. But now I'm looking here. I'm going to not look. I'm not going to not look. And then I'm going to, well, I'm not looking. And you could see he's basically moving towards me. What if I go towards an obstacle like this? I'm going to go towards obstacle like this. And this guy is already around here, right? So now two of our character is behind obstacle, but if I turn, you could see it starts moving towards that player. But if I go behind an obstacle, you could see it's moving. This is now invisible, so it stopped. So again, it works perfectly. A quick rundown that I'll give you is we basically do a random character that we basically take from our array and then add it as a random array, so that we can choose which player to move to. And then this check player is looking or not. We run this every 0.1 second, which is a basic stuff. We basically get all our players. We run and loop. To check if they're looking or not. So in the first loop, let's say the first character, so in the loop we first check if the player is actually looking at the direction or not. If he is looking at the direction, we do the second check, which is a line trace. If he's not looking at the direction, we basically say that is observed is false. But if we are looking at that direction, we also check if there is a wall or not. If there is a wall, then we can basically say that it is not being observed because there's a wall. But if there is no wall, then we can say it is observed, and then we just add a branch condition where it only breaks if it's true. Basically it only breaks if it's been observed by one of it. Okay, this is what the branch does. If it's been observed, then we basically tell that, hey, don't need to check anything else, just stop. It goes back and then just breaks the loop. If this is not true, it is false, then it goes back and then does the loop for the second player, then third player, and whatever the condition that happens, which is observed or not, it is done around here. So the move player, if it has been observed, so you can say that if this hasn't been observed, it gets true, and the last set is been true around here. So we send that it is been observed. if it turns out to be false, it just gets stopped around here. You could say it just gets stopped because nobody's looking. We get false, 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 and that's the value that we send. And move to player does the basic stuff, that is, it gets the value. If someone is looking at it, we stop it. We set is moving to be false. Then we basically check, are we already moving or not? If you're already moving, we stop. We don't do anything. If you're not already moving, we start moving it. That's like very, very basic stuff. It works multiplayer very easily. If you need any help or find a better way to do it, just type it in the comments and I'll try to check it. Thank you.